Okay, good evening, everybody. So let us start. Oh, sorry, I don't have any. Okay, good evening, everybody. So let us start our lecture this evening. I think this will be a very short class. Okay, actually, I think I covered everything, right? So in our last lecture, we discussed. We discussed dynamic data structure like linked list, stack, and queuing also, and there is a tree and graph. Okay, these two are the further topics. So let us see. Do we have any slide for this? Okay, sorry, we don't have any slide for tree and graph and tree, but I do have plenty of stuffs and for tree and actually tree and graph are part of. Oh, sorry. Tree and graph are part of data structure course. So I teach data structure in third another section. So the quick introduction about tree, binary search tree. So tree, just let us give. I am not sure that this will be in your test since I don't see any slides for this, but let us give discuss a few minutes. So it's tree like a non-linear data structure. Okay, so which contains elements that in hierarchical order. Okay, so like a tree, it contains a node and edges. Node means vertex, and edge means the connection between one vertex with another vertex. The connection between one node to another node is called edge. Okay, like for instance, this is a tree, so this is node, these are node. Okay, and then these are edges. The lines are edges, connection are edges. Okay, so in a tree, somehow all the nodes are connected. So for instance, here the very rightmost one is connected with the very leftmost node through its parent. Okay, so this is a way. Okay, there are different kinds of tree. So this, for instance, is tree. There's a term is called path. So from A to J. So there is a way to some edges, A to C, C to F, F to J. So that means this is the path from A to F, A to J, through C and F. This is called a path through connecting edge. Okay, so there is no direct path between H and I, but we can go I through A, through C, go through A, through B, through D, through H. This is called path. And the top one is called root, and these are parent. There are different kinds of trees. Okay, so always there will be always one root, and then based on the number of children. Okay, So you see, for this one, there are maximum of 2 children. So this is called a binary tree. Bi means 2. Okay. So if there are 2 children for each node, if there are maximum 2 children, 2 sub lower level nodes, that's called binary node, binary tree. And there is only one root. And the nodes that do not have any child, those are called leaf. Okay, so you can consider that as a tree if you reverse order, upside down. Okay, so then this is the root and these are the branches, right? So the top one are leaves. So these are branch, sub branch, branch, and the top one leaves. So if there is no branch, then there is a leaf, right? Okay, so based on the numbers of the children in a tree, we classify tree different way, different name. Okay, so it's another term. There's a subtree. So here this part is a subtree. So a tree may have multiple subtrees. So this is a subtree. So this whole thing, that with C and G could be another subtree, and the left side could be another subtree. The total is a tree. Okay. So these are called levels. So the top level is root. Always root has level 0, and then level 1, 2, and 3. Hij are level 3. Okay. So there's a term, the binary search tree. The previous semester we taught binary search tree. So it's binary search tree. Bi means 2. That has true. Binary subtree has true each node has maximum number of 2 children. Okay, this is called binary subtree, most 2 children. Okay, and there are some advantages of using binary search tree. So in the binary search tree, that we can, the top one, this is called binary search tree. That means in a tree, all the left node element is less than its parent, and all the right elements are greater than its parent for every level, every place. You see that for this one, 24, 14, 9 is left side is 9, okay, and the right side is greater than 14, and left side 9 is less than 14. So for all nodes, so if there is this condition exists, then it is called binary search tree. Binary search tree had its advantages and disadvantages. Sorry, it's some advantages to use data structure. Okay, so and then tree traversal, for instance, if you want to go all nodes one time, there are 3 techniques of traversal. It's called in order. That means the root is in so for every, you see that for every node except the child, except the leaves, it has left and right? So this is root and this is left and this is right. So there are 3 orders of traversing. How do we traverse that? How do we go to all of these nodes? So there are 3 orders. This is called in order, then that called pre-order, and then another one is called post-order. So the name, according to name, in order means that your root will be in between left child and right child. So for in order, so you need to go left child first, and then between this one, left child, then root will be inside between left and right, then right. So if you want to do in order traversal for this tree, then we will start from 9, then 24, 14, then 23, then left branch is done, then we will go to the top. This will go as middle before we go to this branch. So then 23, then 30, then here up we will come all the way end. Then 34, then 39, then 47, then this is in order traversal. And then after we complete this left side, we will go root, then 53, and then when you will come here all the way this way. So after 53 we will come here first this way. So here we will consider this middle, so 61, then 72, then 84. Before we come to 84, it has a child, so we need to go 79. So after 72, 79, and then 80. This is one kind of traversal. This is called in-order traversal. There is another traversal. It's called pre-order. Pre-order means you will consider the root first. Pre-order means 53. Then come here, this branch, it will be root first. 30. Then come here, it is root first. Then 14. Then left, then right. Then 9, then 23. Then come here, then root first. 39. Then come here. 34, 47, then come here, root first, 72, then come here, 61, then come here, but this is root, so then 84 and 79. This is called pre-order traversal, and there is one more traversal. It is called post-order traversal. Post-order means the root will go later all the way end. So here left, right, root. Root will be post all the way end. So 9, 23, 40. Then one side is gone. Okay, then here 34, 47, 39. Then 30. So this branch is done. So then come here and then here root letter. So you need to go to here 61. Then here root letter. Then 79. And then it has no right side. Then 84. Then root letter. Then 72. And then root letter. 53. So these are the three different way to do traversal of a binary search tree. So we teach this. We mainly these are part of data structure course. In previous semesters we used to teach this tree, but since we are focusing more on object-oriented programming in this course, okay. So we are not maybe going in depth about this, but I will check if there is a test question from this tree, then I will specifically cover that, okay. And the graph, okay. Graph is another non-linear data structure. So a graph is a kind of tree. But the difference is that in a tree there is in a graph. So in a tree, these two what are this called? Two leaves are not connected. Leaves are connected with their parent, but not each other, right? So 9 is never connected with 23. But here, so for instance, this one is parent. If you say B is parent, then A and D, these are children. So it is possible, yes, A can be connected with D. So if you want to make it a tree, then we need to disconnect this one. We cannot have this connection. It will be. So this is the concept of graph. So for solving many problems, mathematical problem and computer program, we use graph and tree. So in higher level courses, you will see. Oh, sorry. The content is that I teach not this semester. I'm not teaching data structure course. So these are part of data structure, but I'm teaching algorithm analysis. Algorithm analysis is a higher level, next level of data structure. So you took 1321, right? You took 1321, then you are taking 1322, then you will take data structure course, then you will take algorithm analysis and software engineering course. So this is part of this my slide is from algorithm analysis course, not from this course. Yeah, data structure. Similar thing you cover in data structure, okay? So in data structure, in graph, each node is called vertex. Okay, and these are edges. These lines are edges. Okay. So these A and D in tree structure, we would say tree, but if there is no connection from A to D, then we would say tree. And in that case, both it could be a tree and a graph. Sometimes a graph can be called a tree, sometimes a tree can be a graph. But if there is a connection from child to child, then there is not a tree. There is a graph. So based on the graph structure, okay, like we use GPS system, right? Every day we use GPS system sometime. So GPS system, it says like this is a city, another city, it's another city, A, B, C, D are cities, and these are the route from A to B, A to D, B to A. This there is straight line over here, but necessarily not to be straight line. It can be carved or like local highway or freeway type, and some bend. So that means it's this we can say that this city is a B, is maybe Birmingham. It has living cost, some kind of living cost, and it has its own attributes, its features, and maybe this is the distance, and A maybe Atlanta, and D maybe Dallas. So these three cities. Okay, so this A to B is the distance, and shortest distance or straight distance we can say, and B to D is the distance, Birmingham to Dallas distance, and A to Atlanta to Dallas. So there is a Dallas city here, right? A few 30 miles far, 20 miles from here, right? I went there 2 times. I'm talking about that. So in order to develop a GPS type routing system, then a graph is used inside. Okay, its graph contains its value. Its node contains its own value or attributes, and also the distance from one node to another node. Since we're not discussing in depth, so about graph, so I want to skip this because this is not part of this course. We done the So then in the data structure course, so if you understand that linked list, so whenever you take data structure course, so you have my content, okay? So first understand linked list, then stack, then QE, then you will get graph, tree, then graph. And whenever you reach to graph, you see that there are many graph algorithms. Many graphs are graph. There are many algorithms are developed with graph. For instance, sometimes people want to find the shortest distance from one city to another city. Okay, or sometimes people look for minimum cost or maximum profit. So those programs are implemented with graph. So there are many applications for graph algorithm. Okay, so but I'm not discussing this. These are not part of this course. Just I wanted to show you that your next level to explore algorithm, data structure algorithm. So data structure is used, how do you organize your data? So if you can organize your data nicely, then your program will be faster, right? So for instance, if you have 100 or 100 books in your home library, personal library, right? If you put the books randomly, maybe it will be difficult to sometimes find the right book, right? Quickly, right? So later, what we do, we put our books even in our personal library or in shelf in organized way. Especially in large libraries, they put the books in shelf with number so that it is easily identifiable, right? So if they put randomly, that maybe it would take long time. So your data structure course, you will learn mainly how to organize your data. If you learn that, then in an algorithm course, the next level, maybe third year, when you become a junior, then you will take algorithm analysis course. Then you will learn how do you develop. Then first you will learn about existing algorithms. Then by learning, practicing through, then you will learn how to develop your own algorithm. Then you will be understand analyzing an algorithm, whether this is a good algorithm or is there any better algorithm for this, better than for this one. Okay, then you will get a good understanding about programming and problem solving. So for this course in 1321, what you learn basic, how to write a program, how to solve some problems, right? In 1322, you learn object-oriented programming. And next is data structure and algorithm analysis. Then you will have, with the four combination of this course, you will have a good foundation. So in this course, that you got a good foundation about object-oriented programming, right? Object-oriented programming. So this is the only course you will learn object-oriented programming. No other course will teach you object-oriented programming. So I think we have covered everything that was in our module, and my battery is going to die. Let me finish in a quick few seconds. Okay. So you know your test date, final exam. So final exam will be May 6th, 3 p.m. to 11 p.m. Okay, so you need to take your final exam by this time. So please, so there are multiple hours, right? So a couple of hours, you need to, maximum you need to take 2 hours for this test, 3 hours. So check if you have any conflict with another test and let us know. Okay, so my battery is that okay, so our next week, so next lecture, I will not come here, okay? So I will join from home because the previous section has test. Next lecture, okay? So after that, we will have one more week, right? The week, last week. Last 2 weeks, so what do you want to do? Do you want to come here or we want to join from home? Review. I think I've covered everything. I'm done. Yeah, maybe yes, online. Let us meet online, okay? Okay, so for the next, already I see that. Thank you so much for coming. Only 2 people for the last. Okay. So the remaining classes will be, we have maximum 3 meetings, right? So the next class, you better bring your own stuff. If you have something got stuck, if you like me to review, then let us know, okay? So especially, maybe I can review object-oriented programming, abstract class, interface, okay? That will be in a test. Mainly, in a test, you will get major part, substantial amount, maybe 40% at least, from object-oriented programming, 50%. Please review, okay? Please review your test 1 question. And then you will get recursive method, and okay, then a few questions from other sections. Okay, so has anyone any question? People who are joining online? Okay, there are 14 people. Okay, one more request, please. On the test, during the test time, please make sure that you're facing towards your webcam. I don't like you to get caught and get severe punishment for some minor. Even the test result is published. Still, still your test one is being investigated. Okay. So if there is something doubt, then you will face issue. Okay, please do not do that. I believe that I discuss a lot of things, maybe, but all the important thing I emphasize again, and again. If you did practice, then you should have a good foundation in this course. So far. So you learn something new from this course. You learn something new from this course. Now I believe you should learn, whenever you learn object-oriented programming, then you are a good starting foundation. And whatever I discuss in this course, if you learn this, then you will face job interview, internship interview. People will ask this object-oriented programming: what is inheritance? What is polymorphism? What is abstraction? How do you write getter method? How do you write setter method? What is constructor? These are the simple questions you ask. And how do we handle exceptions? Okay. So whenever you have time, please keep practicing this course content. If you are good in this course, then you will be good in data structure. If you are good in data structure, then you are done. The other course will be easy. Okay, has anyone any other question? Do you have any question? Recursive, that was in last test or previous? Okay, so the recursive example, you need to understand one thing majorly. What is the base case condition? First of all, you understand what is the base case. Okay, so if you understand base case, then you are almost done. Okay, base case is the main part of recursion. So for your test, recursive multiplication and recursive, let us go this one. Recursive multiplication, and there was recursive power function, right? Recursive power function. Let us understand these two. So for the test, you are asked, these are the test question. Okay, so the recursive multiplication. So you will be given two numbers, one x and y, and you are asked to find the multiplication of x and y. So then x times 1 is 3, and then it is y 4, then 3 times 4. So how do we do that? This recursive not by multiplying 3 by x by y, but you say x plus x plus x plus x plus x. How many times? Y times. Then you have done multiplication, right? So that means you are going like this: x plus x plus x plus x plus dot 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 plus. How many times? X. How many times? Y times. So here we need to find out the base. So if y is 0, no time, then x multiplied by 0 equal to 0, right? If y equal to 0, then x by x times y equal to 0. So whatever is, if y value equal to 0, then return 0. You understand this concept? So if there is no time, so multiply x 0 times or add of x 0 times, then 0. And then you can write another condition, else if y equal to 1, then return x. You can write this condition, but this is optional. Even if you do not write it, it will work. Else if y equal to 1, then y1, that means 1 time, x equal to 1. X equal to x time. Else, whatever you need to do, x, this x plus the same method we need to call, but we need to, every time we call this method, we need to reduce the value of y. That was a test question, right? So if you understand the recursive method, then is simple. This is recursive multiplication. And it has another version very similar. If you want to do recursive power function, just replace this one, this plus sign by multiplication sign. Okay, this is a multiplication sign. And one thing you know is that, for instance, if you say x and y equal to 1, and x to the power 1 equal to x. If y equal to 1, then return x. And also, you could write this, if y equal to 0, then anything power to the power 0 equal to 1, right? Then return 1. Over here, then you can say else. So then you call 2 to the power 3, then other else you see that it is return x times recursive power, then y. So always this is the base, this is the decreasing, this is converting to the base case. If you use plus sign over here, it will not work. It will be diversing. You need to convert, right, to the base case. So in order to understand recursive method, we start with factorial, find the factorial, right? So please review that lecture. I discuss how to find the factorial in detail. Yes, you must have a base case. Where you will stop? It needs to converse, not diverse. Yes. So which one is converse? So base case is depends on y, right? So this you must y converse y here. Converse means it will be decreasing. It's sometimes y value is 10, right? Then 9, then 8, it will be converging, that it will direct into 0, the base case. Please review my class in previous, the middle of the semester, I will discuss recursive method factorial. Yes, there we go. Okay, has anyone any other question? Any question? So people who are joining online, has anyone any question? Okay, if you don't have any questions, let us wrap up tonight early. And the next 3 lectures, okay? So we will join online. Okay. Join online just from home. And good luck for you, okay? And as I see that, as I told you, I tried my best to explain very difficult tasks in simple way, whatever I knew. So, but these are really difficult tasks. This is why once you understand object-oriented programming, you will get a six-figure job. Whatever I discuss in this course, if you are good in this course, then you will crack a job interview. There will be 80, 90, 100K. So believe me, wherever you go, whenever you go for job interview, you will ask almost same question from this course. Most of the year question in this course. So please, this is the good point. This is the maybe considered as a starting point to learn object-oriented programming. Okay, do not leave up. Do not give up. Okay, do not leave from here. Okay, so people, do you have any question? People who are joining online. Okay, if you don't have any question, then I will wrap up. Thank you so much. Okay, thank you so much, and you have a good day and good semester. Good luck. Okay?